The sum of two forces vector p and vector q is r is such that r is equal to such that r such that vector r is equal to vector p. Oh, resultant is equal to p. Okay. See, again, we have discussed this particular topic, right? Resultant of two vectors being equal to one vector at least, I think, at least 5 to 6 times during the whole series. So, what is the first conclusion when resultant is equal to one of the vectors? So, when the resultant magnitude of resultant is equal to magnitude of one of the vectors, we know that. So, if it is p and q here, we know that 2pq into cos theta would be actually equal to minus q square, right? So in this case, what is 2q, sorry, so q, and so what is 2p cos theta is equal to 2p cos theta, q will be equal to minus q squared by q, which is equal to minus q. Now what is the angle? The angle alpha is actually equal to 2p sine theta, where theta is the angle between p and q, 2p sine theta by q plus 2p 2p into cos theta. Now have a look here. What is 2p into cos theta? 2p into cos theta is given to us as minus theta, which means this much fraction becomes minus theta. So what we get is alpha is equal to 2p sine theta the whole by 0, which means this is actually tan alpha is equal to. So tan alpha is equal to 2p sine theta by 0 is infinity. So tan alpha is equal to infinity, and therefore alpha is equal to tan inverse infinity, which is pi by 2. And therefore the correct option here would be pi by 2. Again, less than 2 minutes. Straightforward question. I think this part was previously we have solved this, but this asking the resultant and the angle made with the resultant was for the first time in the at least for the past 5 to 6 years. No issue. So let us now try to understand the derivation in detail. So what we have here is two vectors, vector p and vector q. Let us assume that they are acting like this. So this is vector p and this is vector q, and we know that the resultant would be like this, right? Resultant vector r, and the angle with the resultant makes with one of the vectors p is theta, is alpha, and that the vectors make with themselves are theta. Okay. In this case, what is magnitude of r is equal to? We know that magnitude of r is equal to magnitude of vector p plus vector q, which is equal to root of p square plus q square plus 2pq cos theta, which is equal to, okay, so according to the question, it is given that magnitude of resultant is actually equal to the magnitude of one of the vectors, vector p. So this is equal to p. Okay. In which case, what can we write? We can write here, if we take square on both sides, what do you get? This implies p square plus q square plus 2pq cos theta is equal to p square. Now p square and p square minus 0. So what we get is q square plus 2pq cos theta is equal to 0. And what we get is 2pq cos theta is equal to minus q square. And therefore 2 into p, q by q square is minus q. So 2p into cos theta is equal to minus q. Now the radius than the angle theta in 2p and q. Now what is given in the question is this p is being doubled, right? So now we have alpha here, but instead of p we got 2p, and then we have got vector b, right? So we've been asked to find out this alpha. Now what is the angle what is the angle that the resultant makes with one of the vectors? So that is expressed by tan alpha is equal to 2p into, in fact it is actually p into sine theta. Instead of p we have the new vector here, which is 2 times vector p, 2p into sine theta by the second vector, which is this vector q, which is vector q plus 2p into cos theta. And if you analyze this equation here, what is 2p into cos theta? It is minus q. You bring this here, so 2p into cos theta is minus q. So what we get is 2p sine theta by q minus q, which is equal to 2p sine theta by 0. Anything by 0 is infinity. So what we get is tan alpha is equal to infinity, and therefore alpha is equal to tan inverse infinity. And what is tan inverse infinity? It is pi by 2 or 90 degrees. Then the angle theta in degrees, okay, it is in degrees. Oh my god, we just made a big mistake. So it's not pi by 2, it is 90 degrees.